Hi guys, going to be vodcasting the quick solutions to the Burrito Battery Lab, and even though this is one I believe everybody finished in class, I want to stay consistent and make sure that we review all labs on vodcast. Hope you're having a good night. So, where do you think the motor, forgot my I apologize, is getting the electricity needed to turn? Okay, and this is a very, very straightforward answer. It's from the electrons transferred during the redox reaction. Done. Alright, so it's basically talking about this single replacement reaction, that is the force that's providing these spontaneous electrons to be generated. So let's balance this. You should get aluminum 0. You should end up with Mn 2 plus, SO4 2 minus. We're going to be taking aluminum up to 3 plus. We're going to be taking manganese down to 0. And SO4 is going to be our spectator ion. Now, I was working with a student after school today, and she, a lot of times people are making this mistake. They're writing something like this. So they're doing the crisscross with the Al and the Mn. I want you to look at this very closely. Notice that Al is positive and Mn is 0. Positive and 0 will not stick together. Only positive and negative. Just wanted to clear that up. So that is why we're always writing these two products as separate from one another. How would I categorize this reaction? I have it up and down. There's the Blue Angels. Woo! Categorize it as redox. If you want to be super specific, you could call it oxidation reduction. Provide the half reactions. Okay, so the oxidation half reaction is the reaction where aluminum 0 is converted to aluminum 3 plus, and it actually loses 3 electrons. The reduction half reaction is when Mn 2 plus gains 2 electrons and is converted to Mn 0. Calculate the E cell, which is equal to negative E ox plus E reduced, which is equal to a negative, whatever the value for aluminum is, and according to my periodic table, that's a negative 1.66 volts, and we're going to add that to the manganese, which is negative 1.18, and that's going to give you a 0.48 voltage. Calculate the Gibbs free energy. So delta G is equal to negative N F E cell. So delta G is equal to negative something. We don't know what that value is yet. 96,500 multiplied by 0.48 volts. This value is 6, and it's the number of electrons transferred. And let's see if we can see that. Well, these 3 electrons are going to here. But we notice that the manganese only needs 2 to be reduced to the manganese atom. So really the 3 and 2 isn't going to work. There's got to be some common multiple between the 2 that is actually occurring, and that value would be 6. So in reality, 2 aluminums reacted with 3 manganese to make this reaction happen. So we're going to go up here and we're going to rebalance. No, I'm sorry. 2, 3, 2, 3. Alright, now I'm going to let you guys do the calculations again for this. You're going to get some big number here. It's going to be in joules, but the big deal is that it's negative, and then you're going to take your negative big number and you're going to say that there are 1,000 joules in every 1 kilojoule, and you're going to get some smaller big number. And basically, it is spontaneous for reason 1, E is greater than 0, and reason 2, delta G is less than 0. Alright guys, makes good battery. Take care. Have a good one.